For decades, humanity has basically been on this relentless search for the ultimate energy solution. We've burned coal, tapped into natural gas, harnessed the wind, and, of course, captured the rays of the sun. But what if the ultimate answer has literally just been staring us in the face the whole time? Today, we're diving into stellar ambition, the promise of nuclear fusion. Seriously, what if humanity could unlock a nearly limitless source of clean energy? We're talking about an energy source so unbelievably dense that just a microscopic amount of fuel could power entire major cities. I know, it sounds totally like science fiction, right? But actually, this is a very real, very active area of scientific pursuit. Because if we can master nuclear fusion, it will permanently transform the future of our planet. Section 1. The power of the sun, our solar system's biggest reactor. Okay, so picture this. Deep inside the sun, you have this extreme heat and just crushing pressure forcing simple hydrogen atoms together. They're moving at absolutely incredible speeds, and they actually overcome their natural repulsion to combine or fuse. And in that exact, precise moment of fusion, a massive amount of energy is released as light and heat. That same energy travels a staggering 150 million kilometers across space, and it powers virtually all life right here on Earth. Section 2. Fission versus nuclear fusion, two different nuclear paths. So naturally, scientists want to recreate this cosmic process right here on Earth. But let's clear something up first. When we hear the phrase nuclear energy, we almost always think of traditional fission, splitting large, heavy atoms apart to release energy, like what powers today's nuclear plants. Well, fusion is the exact opposite. It works by combining small atoms together. Basically, by fusing small hydrogen isotopes like deuterium and tritium, the process just yields a harmless helium atom and, again, a truly massive release of energy. The sheer scale of the benefits here is just incredible. First off, operating a fusion reactor produces absolutely zero carbon emissions. Zero! And because the fuel can be sourced directly from seawater, well, the supply is practically inexhaustible. It's like having an infinite gas tank. Plus, unlike traditional fission, it creates far less long-lived radioactive waste. So, theoretically, fusion could provide the entire world with clean energy for thousands of years. Just let that sink in for a second. Section 3. Containing a star on Earth, the ultimate engineering challenge. So, you're probably wondering, if it's so great, why don't we already use this? Well, it really comes down to a number, 100 million degrees Celsius. See, because we don't have the immense gravitational pressure of the sun's core right here on Earth, we actually have to compensate with pure heat. Scientists literally have to heat the fuel to a temperature significantly hotter than the center of the sun itself. We are quite literally trying to build machines that can contain temperatures hotter than a star. And at 100 million degrees, atoms break down and become plasma. That's a superheated, highly charged state of matter. But here is the ultimate engineering hurdle. There is absolutely no physical material in the universe that can directly contain plasma at these extreme temperatures. If it touches the walls of any physical container on Earth, that container just instantly melts and the fusion reaction instantly stops. So how do you control the uncontrollable? Well, scientists use invisible boxes. They use incredibly powerful magnetic fields to suspend, squeeze, and control the plasma right in midair, keeping it safely away from the physical reactor walls. These magnetic fields are generated inside absolutely massive, wildly complex machines called Tokamaks and Stellarators. Keeping 100 million degree plasma perfectly suspended using just magnets, that is arguably one of the greatest scientific challenges humanity has ever undertaken. Section 4. The future of human energy, from science fiction to reality. For decades, fusion was kind of the running joke in physics. It was always 30 years away. But that narrative is rapidly changing right now. Recently, everything has started to shift. Researchers have achieved major breakthroughs in actually sustaining these incredibly volatile reactions. Reactor efficiency is improving dramatically. And because of this momentum, governments and private companies are suddenly pouring billions of dollars into fusion technology. The progress we're seeing is so rapid right now that many experts honestly believe commercial fusion power plants could become a working reality in the coming decades. And if we actually cross that finish line, the impact is going to be monumental. Now, to be fair, it won't happen overnight, but the long-term potential means drastically cleaner air for our cities, a massive reduction in global carbon emissions, and abundant electricity for everyone. It wouldn't just be a new power plant. It would literally mark the dawn of a completely new era of sustainable energy.
So what does this all mean? Is nuclear fusion the next giant leap for humanity? It is genuinely awe-inspiring to think that the exact same fundamental force that powers the stars in the night sky might actually one day power our homes, our cities, and our entire future. I really hope this explainer illuminated some of the incredible science behind it for you. If you enjoyed this breakdown, make sure to like, subscribe, and follow for more amazing science and future technology content. Keep learning, and I'll see you on the next one.